Since we've defined the derivative at this point, and we've talked about how a derivative is the instantaneous rate of change of a function, we can estimate that derivative in a number of ways. So first of all, because the derivative describes the instantaneous rate, like I just said, anywhere that we can estimate that rate, we can estimate the derivative. So in other words, we can estimate where that rate is estimated, and estimating a rate is really just finding average rate. So if we can find an average rate, that lets us estimate the derivative, because the derivative is just a more precise rate than the average rate. So with a graph, this involves looking at a slope, and with a table, it involves constructing a difference quotient. So let's do a couple examples for the graph. If we want to find f prime of 1 for the functions depicted, well, we just have to look on the graph here. So f of 1 is right here. And so the difference quotient, or the average rate of change, will be the slope of this line right here. And if we look, we can get a close enough estimate by saying 0.6. So f of 4 minus f of 0 over 4 minus 0, which is just going to be 6 minus about 1 over 4, which means 5/4. So the f prime of 1 of this function is about 5/4. For the second function, we're going to just draw in kind of a tangent line there. And we're just going to estimate what this is. So right here, I'm going to say that's about, it's probably about -2. So over the width of 1, we rise -2. So delta y is equal to 2. Delta x is equal to 1. So f prime of 1 is approximately 2 divided by 1. F prime of 1 is approximately 2. So again, the estimate is just trying to estimate the slope from the graph. In some cases, we can actually do a calculation. In others, we just kind of have to eyeball it. If we have a table, same idea. We need to find a difference quotient to get the most accurate estimate. So if we want f prime of -14, we know -14 happens between -15 and -13. So the difference quotient will be f of -13 minus f of -15 divided by -13 minus -15. And this will give us -63 minus -69 will give us +6. And -13 minus I think I got that backwards, -13, this will give us -6. And then -13 minus -15 will give us 2. So the f prime of -14 is approximately -3. Now if we come down here, we notice that -14 is one of our values in the table. So we have to choose what's the best difference quotient here. And as we've said before, the best, most accurate difference quotient is the one with the smallest x interval. So if I did 16 and 13, -16 and -13, that's a spread of 3. If I do -16 and -14, that's a difference of -2. But if I do -14 and -13, that's a difference of -1. So this right here is my best interval to do the difference quotient over. So f of -13 minus f of -14. And again, you can do these, you can switch whichever order you want to write these in. So if you preferred to write -14 minus -13, that's totally fine. Oh, these should be, that's wrong. It should be negative 13 minus negative 14. So 95 minus 89 will give me 6. Negative 13 minus negative 14 will give me 1. So f prime of negative 14 is approximately 6. And those are the kind of two main ways that we'll end up estimating derivatives, from graphs and from tables.